Chapter 7, Section 3 is about scientific notation. In this section, we are going to be going over how to write something in scientific notation, how to take something that's already in scientific notation and rewrite it out in standard form, and then we'll also go over how to do some operations with numbers that are in scientific notation, like multiplying and dividing. The first thing I want to go over is if you have a number that's written in what we call standard form. So it would look like just like a normal number, but it's probably a very large number or a very small number. We're going to talk about how to write it in what we call scientific notation. Now you've maybe seen scientific notation before, like in a science class, because you're dealing sometimes with measurements that are really big or really small, depending on if we're talking about things within the world. Like planets would be something really large. Something really small would be like in science would be looking at bacteria or the growth of something. And so we have these ways to represent these really extreme numbers into something that's a little bit more manageable to work with if we're trying to do operations with them. So if you have something that you're trying to write in scientific notation, you want to make sure that the decimal point is right after the first non-zero digit. So you want to move it all the way to the left. That follows like that first whole number at the beginning. Then you're going to have to remember like how many times did you have to move that decimal place. So when you had to move it from a new, like a part to, if you had to move the decimal point to a new part of the number, you had to figure out how many times did you move that decimal. Did you move it 5 times, 6 times, 3 times? And then you also need to take point of like, where did you move it? Did you move it to the left or did you move it to the right? Because right here in this box, if you moved it to the left, you're going to multiply by 10 raised to a positive exponent to represent scientific notation. If you moved it to the right, you're going to have a negative exponent. And that just lets the person know when they're looking at the number, whether the number that they have in scientific notation started either as a really big number or a really small number, depending on which direction the decimal point was moving. So let's take a look at an example. Both of these numbers would be considered in standard form. And you can see how the one on the left is really large, the one on the right is really small. And so what I'm going to do is think about, on this large number, where's the decimal point at right now? All whole numbers always have a decimal that sits at the very end of them. We normally don't write them, but in this case we need it because we need to move it to write this in scientific notation. Now I want to move this all the way over to the left so that it goes right after that too. So I'm just going to start moving, and what I do to count is I kind of just do like little loops or kind of just little, I don't know how you want to call them, like swoops I guess, underneath the digits. So 1, 2, 3, 4, 5, 6, 7, 8. So I had to move it 8 spaces to the left. Okay, so what I'm going to do is rewrite this as 2.01. Now I don't need the rest of those zeros because that's the reason why we're rewriting this, is trying to take this really large number and make it a little bit more manageable. But now I need to write it out in that scientific notation form. So I do times 10, and then I moved it to the left, so I'm going to follow this first rule right here. And I moved it to the left, we said 8 times, so my exponent needs to be a positive 8. Now for this other one, this one on the right here, again I need to move my decimal place. This time though I'm going to move it to the right because I need it to go in between that 5 and 1. So we're going to go 1, 2, 3, 4, 5 to the right. So I would write this as 5.1 times 10. And since we moved it to the right, now it's going to be negative, and I moved it 5 times. So hopefully you can see that they're very similar in kind of how they work as far as how you write the numbers. You want to have one whole number and then your decimal. So you can see how I had 2 and then point and 5 and then point. And then that exponent really all depends on what direction you moved. So because we moved to the left on the first one, it's a positive 8. And we move to the right on the second one, it's a negative 5. So I want you guys to try to practice. For this first one, I would have moved your decimal point so it came right after the 2. So 2.115. You don't need any of those zeros after it. And then times 10, and you had moved it 7 times to get it over there. So it should have been 2 to the 7th power. For the second one, you're moving it to the right 1, 2, 3, 4, 5, 6 times. So this should have been 1.45 times 10 to the negative 6 power because you went to the right. Now the next thing we're going to do is go the opposite direction. So I'm going to give us something written in scientific notation and we want to get it back into standard form. Okay, in order to do this, you need to make sure that you take a look at your exponent. You need to decide, is it a positive or a negative number, because that will tell you which direction they had moved the decimal point. If your exponent is greater than 0, that means that it's positive. That means that you moved the decimal places, you moved it to the left originally. So in order to rewrite it in standard form, you'll now have to move the decimal place to the right, and you'll have to add on those zeros. If your exponent is negative, then you'll have to move it to the left and add zeros in to fill in those empty spaces. So we're going to practice here. We've got 6.32. So normally what I do is I write that number out, and then it says 10 to the 9th power. 9 is positive, which means I'm going to move my decimal to the right. So I'm going to be making this number bigger. And so I'm going to just count that out. Again, kind of drawing those little lines underneath my numbers here. And I'm going to have a lot of empty spaces because I have to move this 9 times. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9 times. And that's where the new decimal is going to go. Now with all of these empty spaces here, you need to fill them in with zeros. So I have 632 here, and then I have 7 zeros that follow that. And then I'm just going to add in my commas in the appropriate spot. So remember, you start way over here, and then you count in 3, comma. And this should be your new number. So we're going to do the same thing with the second problem. This one's a 4. Remember, your decimal for this one sits after that whole number. Now this exponent is negative, which means I need to move it to the left 7 times. So 1, 2, let me start that over. 1, 2, 3, 4, 5, 6, 7. Here's your new decimal, and then we're going to fill that in with zeros. So I have 6 zeros before that 4 now. I usually always put 0 point just because I like to have that 0 in the front, but you don't have to do that. You could just do point and then do your 6 zeros and your 4. Okay, go ahead and take a minute to do those 2 practice problems. So for this first one, you needed to move it 5 times to the right. So 1, 2, 3, 4, 5. Fill in with zeros. So you should have added 3 zeros here. So this should have come out to be 781,000 for your new number. For this next one, we're moving it to the left 3 spaces. 2, 3. And fill that in with zeros. So now I wrote 0.00314. Okay, the last thing that we're going to be working with here is starting to do operations with scientific notation numbers. We're going to talk about multiplying and we're going to talk about dividing. When you're dealing with scientific notation, we're going to do something similar when we were multiplying and dividing like our monomials in the previous two sections. You're going to want to like pull the regular numbers and work with those first by just either multiplying or dividing them. And then you're going to look at the times 10 pieces, because with those exponents, that's when you're going to either add the exponents or subtract the exponents, whether you're multiplying or dividing, to get your new exponent. Now we will have times though that the number that we get after we kind of do our process isn't in scientific notation, and so then you'll have to write it in scientific notation again. And so you'll have to maybe move the decimal place. And we'll kind of show you how that works and kind of what you're going to want to do. But before we get too far into that, I just want you to write yourself these two notes up here, and they'll make more sense as we start getting into these examples. If you have to, after you have your answer written out, but you don't have it in scientific notation, if you have to still move your decimal to the left, so if you have to move to the left, you're going to have to add. If you move to the right, you will have to subtract. These will make more sense once we get into some examples and I can actually show you what I mean by these two little rules that I'm having you write down here. Okay, so take a look at this first example. We have 3.5 times 10 to the negative 3, and we're multiplying that to 7 times 10 to the 5th. The first thing I'm going to do is kind of regroup. I'm going to group my numbers out front together. So that's 7.5 and that's 7. We're going to multiply those. And then we're going to deal with the 10s. So I've got 10 to the negative 3, and I'm taking that times 10 to the 5th power. So 3.5 times 7, we're going to do that first. That comes out to be 24.5. And then for my 10, so times 10 here, negative 3 and the 5 you're going to end up adding because we are multiplying. So back in section 1 we talked about multiplying monomials. With those exponents you add. So negative 3 times 5, plus 5 would be 2. Now, this number, though, is not yet in scientific notation, because remember the rules for scientific notation say that the decimal needs to be after the first non-zero digit. So I still need to move this decimal one place to the left. That's when these rules up here come in, because then you have to change this exponent here, this 10 squared, because we're moving the decimal, so it's going to affect that exponent. So when I said add up here, what I meant is that to that current exponent, you are going to add the number of times that you had to move that decimal place again. So I had to move it one time to the left, so I'm going to add 1 to the 2. So my final answer here is going to say 2.45 times 10 to the 3rd now. Something that they might also want or ask for in some of these problems is for you to then, after you have it in scientific notation, write it back out in standard form. And so if I did that for this one, I would have to move this decimal place 3 times to the right. And so the standard form would be 2,450. They may not ask for that, but sometimes they do. Okay, so just to kind of summarize that, I multiplied those numbers that sat out front. Then I dealt with the exponents on the 10s, and this time I added them because I was multiplying. And then my number still wasn't quite yet in scientific notation, so I had to yet move that decimal one more time to the left. And so I had to add 1, because I moved it one time to the left, to my current exponent. And that's how I got 2.45 times 10 to the 3rd. Now, the other thing that I'm seeing here on this next example is that I have this 5.3 times 10 to the 3rd power, and I'm raising that to the 5th power. This is that power of powers rule that we talked about in section 1. So in order to do this one, remember what we did with this exponent is we distribute it into the parentheses to both of those terms. Okay, so you are going to take 5.3 and you're going to raise that to the 5th power. And I would use a calculator to help you out here because I don't know what that is even myself. Okay, so when I do that, I get this pretty crazy big number that's a decimal. And I'm going to write out the whole thing. So it's 4181.95493. Okay, that's the 5.3 to the 5th power. Now remember with the 10, you're taking that 3 times 5. So that becomes 15 because that power of power said that when you had to do the exponent on the outside like this, you have to multiply them. So it's a little bit different looking than that other one on the left side of the screen there. Okay, these are two different problems. So this is not quite yet in scientific notation. I need to move this decimal, again, over here by the 4, so I'm moving it 1, 2, 3 times. So now it says this, 4.1819549.3. Okay, but I had to move that 3 times to the left. So again, up here, moving to the left means we add. So I need to add 3 to that 15. So this becomes times 10 to the 18th power. Then again, if they did ask for this to be in standard notation, this would be a huge number because I would need to move this 18 times over here to the right. So you're going to have all those digits. After that, you're going to have 10 zeros. That's a huge, huge number. Okay, so I want you guys to practice. If you need to, I would pause the video here, take some time to do these 2 problems, and then come back and keep watching to see what the answer should have been. So for this first one, I took 6.5 times 8.7. I got 56.55. Then that's times 10. I had to add. So 12 plus that negative 15 comes out to be negative 3. I'm not quite in scientific notation yet. So I had to move this 1 to the left, which means I needed to add 1 to that negative 3 up there. And so my answer was 5.655 times 10 to the negative 2 power. And if you also wrote it in standard form, it would be 0.05655. For the second one here, we take this 2 and we distribute into the parentheses there. So 7.8 squared comes out to be 60.84. And then that's times 10. You take 4 times 2, which would be 8. So times 10 to the 8th power. Again, though, I have to move this 1 time to the left. So I have to add 1 to my 8. And so I got 6.084 times 10 to the 9th power. And so then the standard form of this one would be 6.084 0, 0, 0, 0, 0, 0. So the last piece here is dividing. And dividing works very similar to multiplying does. You're going to divide your numbers. This time, though, with our exponents, we are going to be subtracting them because we're dividing instead. But then you may still have to write something in scientific notation even after you get your answer, and that might involve just moving decimals again, like we were just doing with multiplying. And so those same rules that I had you add up above on the top of this page still apply here for division. So for this first one, I would divide, the 3.066 by the 7.3. For your 10 to the 8th power over that 10 to the 3rd, you are going to end up subtracting those exponents. Okay, so when I took 3.066 divided by 7.3, I got 0.42. And then when I took my exponents and I subtracted here, I have 10 to the 5th. Now this one, it's not in scientific notation because remember that decimal has to come after the first number that we see. So we do actually need to move this one to the right though this time. So back up here, when we talked about those rules, I said when you move it to the right, you have to subtract the number of times that you move the decimal. So I actually need to subtract 1 from the 5. And so my final answer is 4.2 times 10 to the 4th power. And again, I'll write this out in standard form. This would be 42,000 if I were to move that 4 times to the right. So I want you to take a minute and do that practice problem. So for this one, I started first by dividing 40.3 by 3.2. I got 12.59375. And then that's times 10. And then I had to subtract 5 minus 3, which would be 2. I needed to move this 1 time to the left so that I could get it after that 1. Since I moved it to the left, that means I need to add 1 to my 2. And so I had 1.259375. And that is then times 10 to the 3rd power. And standard form, if I move this 3 times to the right, it comes out to be 1,259.375.